best way to prevent an oil well blowout is to be alert to changes in drilling rate and mud pit level, maintain a good mud program, and avoid swabbing. But abnormal formation pressures can surprise even a careful crew. What is there to back you up in such a case? The BOP stack. Your life depends on it, so you'd better keep it in good condition. In this program, we'll look at the Hydril Annular BOP and make sure you know how to maintain it. We'll examine two types, the GK, which is simpler and found on many land rigs, and the GL, a little more complicated, well suited for subsea drilling, but also used on some land units. Both preventers have two moving parts, a rubber packing unit that performs the sealing function, and a piston. Upward movement of the piston squeezes the packing unit into the bore. The annular preventer will, of course, seal off against anything in the bore, drill pipe, tool joints, cable, or Kelly. Or, if you've pulled out, the packing unit can close completely, shutting off the entire hole. Complete shutoff of the annular BOP on an open bore should only be performed in the event that your blind rams fail or can't be used. The annular also allows stripping, so you can run the drill string back into the hole under kick conditions. The annular's hydraulic operating fluid is light petroleum hydraulic oil or a mixture of water and water-soluble oil. Closing pressure will be applied here at the closing chamber. When we apply closing pressure, the hydraulic fluid forces the piston upward. Pressure applied to the opening chamber pushes the piston down, allowing the packing unit to return to its normally open position. In addition to the opening and closing chambers, which you'll find on a GK-type BOP, the GL BOP has another chamber. It's called a secondary or balancing chamber, and it can be used in one of three ways. The standard hookup is shown here. The opening chamber is connected to the secondary chamber. The advantage of this standard hookup is that it requires the least volume of control fluid. An optional hookup connects the secondary chamber to the closing chamber. Closing pressure is now exerted here and here. This reduces the closing pressure required by nearly a third. Now it takes less pressure to close the preventer, but it does take more fluid, so it's a little slower. If you're drilling in deep water, the GL can also be connected in a third way. In this hookup, the secondary chamber is connected through an interface accumulator to the marine riser. This is called a counterbalance hookup. In deep subsea applications, the weight of the column of mud in the marine riser exerts a significant downward or opening force on the packing unit and piston. In a counterbalance hookup, the pressure of the mud is also applied here at the secondary chamber, where its closing pressure offsets the opening pressure of the mud. The pressure on the packing unit and piston is now balanced, giving you efficient control of the BOP using normal closing and opening pressures. With this hookup, you won't have to adjust your closing pressure regardless of the water depth of your stack. It's very important that you always hook up all three chambers on the GL BOP. The GL won't operate correctly if you leave the secondary chamber plugged or exposed to seawater. Now let's open up a GL preventer and see what's inside. Before you disassemble a preventer, open the control system valves and loosen the hydraulic connections to the BOP to allow any trapped pressure to leak out. This is a safety precaution to keep you from getting hurt. To release the head, back the jaw operating screws out about 4 turns.
Back with the wrench all the way so we can count the turns. Keep on going, keep on going.
The screws operate these jaws inside the preventer. The jaws have to be retracted in order to remove the head. You should be able to feel the jaw's shoulder against the body. Don't force them. Remember, it's about 4 turns.
Excellent.
Now, take out all the pull-down bolts on top of the head. Unload the head evenly by loosening one side, then the opposite side, rather than going around the preventer. Install 3 eye bolts, a triple chain sling,
Keep going.
Lift the head slowly so you don't catch it or bang it on other preventer parts.
Move the crane that way if you can now.
That's the head. Next is the packing unit. It'll lift right out with the help of a couple of eye bolts. Install 3 eye bolts in the opening chamber head. Lift it carefully with the triple chain sling. You may have to tap it with a soft head hammer or shake the sling to get it loose. The trick is to keep it level so it won't bind. That's the opening chamber head. Next is the piston. Install 2 eye bolts. The wall of the piston is a critical sealing surface, so it needs to be protected. Put a couple of wooden spacer blocks between the eye bolts and the wall so you won't damage it. Once again, lift carefully. Now unscrew the cap screws around the slotted body sleeve. No, it's not easy, but there are some critical sealing surfaces and seal rings down there that you need to check. Hook a sling in the slots of the sleeve to lift it out. That's the slotted body sleeve. Now, the outer body sleeve. It'll lift right out. That's the complete preventer. The body, the packing unit, slotted sleeve, the head, the outer body sleeve, piston, and the opening chamber head. If you have a GK type of preventer in your stack, you'll find it's like the GL but with fewer parts. First, remove the locking screw. The GK head will unscrew. The internal parts of this BOP include the packing unit and piston. The annular preventer is pretty simple, and it doesn't need a lot of complicated maintenance. It's awfully important, though, so give careful attention to the things it does need. Routine cleaning and inspection, packing unit testing, packing unit replacement, and seal replacement.
Okay.
Once you've disassembled a unit, check the inside walls of the body. Repair minor pits and scores with emery cloth. If there are bad pits or scores, machining or welding is probably needed, and that's a shop job. Inspect the body sleeves for damage or wear. Look at the piston for pits or scores, and check the bowl of the piston for pits or gouges. Smooth any rough areas with emery cloth, a file, or a grinder if necessary. The bottom of the head may have grooves caused by wear from the steel segments of the packing unit. If you think they're excessive, ask your tool pusher to take a look. If it needs repair, it'll have to go to the machine shop for welding, machining, and stress relieving. There are several sets of seal rings in your preventer that serve to isolate the various operating chambers from each other and from the annulus. On the GL, these sets of rings seal off the secondary chamber. This set forms a seal between the opening and closing chamber. And these two seal off the opening chamber. There's also an O-ring on the preventer head, and one between the outer body sleeve and the body. A GK type preventer has fewer rings on the piston and on the head, plus the head gasket. Check every seal ring for nicks, cuts, fraying, or abrasion. If a ring looks bad, get rid of it. It's a small price to pay for your safety. The GL and large GK preventers have some individual seal rings and some that require backup rings on either side. Pay attention to what you take off so you'll know what to put back on. Inside the preventer body, where it mates to the body sleeve, an O-ring. On the outer body sleeve, a U-seal ring and two backup rings. On the piston, a U-seal ring and two backup rings. And another U-seal ring with backup rings. On the opening chamber head, a U-seal ring inside and a gasket on the outside. And on the preventer head, an O-ring and a U-seal ring. Be sure to read the Hydril operator's manual and point the sealing lip of the ring in the right direction, in this case, up. Coat the new rings with silicone grease or castor oil. A petroleum-based grease or oil would shorten the life of the seals. The packing unit is synthetic or natural rubber, molded around a ring of individual steel inserts. We've exposed one insert here to show you. You really can't tell much about a packing unit just by looking. This one looks torn up, but it may perform its job perfectly well. The only way to be sure a packing unit is bad or still good is to perform a test closure of the BOP. This is covered in the operator's manual and later in this program. Hydril makes 3 types of packing units. For use with oil base or oil additive mud, there's a synthetic rubber packing unit. This should be used only at operating temperatures above 20 degrees Fahrenheit. This type of packing unit is identified by a red band. No color band indicates a natural rubber packing unit designed for drilling with water-based mud. The green band signifies a neoprene rubber packing unit. This is for use with oil-based mud at low temperatures. You've probably heard that you can replace a packing unit while there's pipe in the stack simply by cutting through it and slipping it around the pipe. You can, but there's an easy way and a hard way. Ready, men? Go. On the left, Steve is huffing and puffing. He's doing it all wrong.
You look like you could use some Gatorade.
He's using a saw instead of a knife. He isn't lubricating the rubber, and he isn't keeping tension on it. Mario, on the other hand, seems to be having a good time. He's using a knife, oiling the rubber with castor oil, and prying between two of the steel inserts to keep tension on the rubber.
Okay, go back and keep cutting.
Go like this.
Hold it. Hold it. Hold it.
It took Mario about a minute. Steve's going to be at it all day. A common method of keeping tension on the packing unit you're removing is to tie a couple of ropes around it and pull from opposite directions. Never use a saw on a new packing unit. It'll tear the rubber, ruining the packing unit. Before we assemble our GL preventer, let's look at one more maintenance procedure you may run into. These latching jaws are replaceable in case they get damaged. Pull the plug from the jaw operating screw. Remove the sleeve screw and spacer sleeve. Now, the jaw is loose and can be removed from inside the body. The sleeve screw holds the jaw to the operating screw, so that turning the operating screw moves the jaw in or out. To install a jaw, place it in position, screw the operating screw in hand tight. Now install the spacer sleeve and sleeve screw and tighten it to about 90 foot-pounds. We're ready for reassembly of the GL. First the O-ring and a little silicone grease. Now lubricate the outer body sleeve. And lower it into the preventer. Be sure to remove all eye bolts. Lubricate the slotted sleeve. Clean the cap screws. And you'll find it a big help to use some zinc-based pipe dope on the threads. Look at that jaw on the left. It should look like the one on the right. Do a little more scrubbing in there if you didn't catch it the first time. Some pipe dope on the jaws will keep them from binding next time you have to take the preventer apart. Don't put any dope below the jaws. Lubricate all the mating surfaces of the piston. Remember to use a silicon-based lubricant or castor oil. Now, carefully lower the piston into the body. Line it up carefully. Watch for pinching of the seals. Next is the opening chamber head. It may not seat completely into place. The preventer head will force it into place if you have it aligned correctly. Be sure to lubricate the piston bowl before you lower the packing unit into place. Make sure you've gotten all the eye bolts. Now some lubricant on the head and pipe dope on the locking rings. Lower the head and pull it down with the 4 pull-down bolts. There shouldn't be more than 50 thousandths of an inch clearance between the BOP head and body. That's too much. If you try to engage the jaws now, they won't mesh, giving you the false impression that the head is on tight. That's better. Now rotate the jaw operating screws clockwise to engage the jaws. If they don't rotate 4 turns, the jaws aren't meshing. Apply 300 to 400 foot-pounds of torque. Don't forget now to retighten the hydraulic fittings. You should disassemble your BOP at the conclusion of each well. Inspect it, clean it, and lubricate it. Replace seals if necessary and make any repairs needed. Occasional test closures of the preventer will enable you to check the packing unit. Only through test closures can you be sure your BOP can seal off a hole under pressure. You should perform a surface test between wells and whenever you replace a packing unit. On land operations, this thorough test can be done every time you test close the BOP. The standard offshore procedure is to clamp the stack on the test stump and fill it with water. Make your test closures on the recommended size test pipe. Before you close the preventer, insert a piece of welding rod into the test hole in the head. The rod will rest on the piston. When the piston moves, the rod will move. Mark on the rod at the top of the head. Now close the preventer. Pressure up through the test stump to the test pressure you've been instructed to use. Use just enough closing pressure on the preventer to seal off the simulated downhole pressure. If you can't get seal off, you immediately know something's wrong. Even if you do get seal off, mark the rod again at the preventer head. The distance between the marks is the measurement of the piston stroke. Determine the maximum piston stroke by looking in the operator's manual or at these measurements stamped on the head. These give you the maximum distance from the top of the head to the top of the piston with the preventer open, and the minimum distance from the top of the head to the top of the piston with the preventer closed at full stroke. Obviously, if you take the difference, you'll have the very longest piston stroke possible. Your piston stroke won't be this long because a good packing unit will seal off before the piston reaches its upper limit. Compare the measurement of your piston stroke with the maximum stroke. As your packing unit wears, these figures will get closer and closer. When your actual piston stroke approaches the maximum possible stroke, you'll need to replace the packing unit because you need a margin of safety, and it may take more piston stroke next time you close the preventer. How much safety margin you require will be determined by your tool pusher. Store spare packing units and seal rings in a relaxed position, preferably in the box. Keep them in a cool, dark, dry area away from electrical machinery or other areas of ozone concentration, so they'll be in good condition when you need them. Now you've seen how simple the Annular BOP is. Can you remember the basic maintenance practices? How do you check the packing unit for wear or fatigue? By making routine test closures and measuring the stroke of the piston. What should you do with the BOP after completing a well? Disassemble it, inspect it, repair, clean, and lubricate it. What should you inspect? Examine each part, looking for nicks, burrs, or scores in the sealing surfaces. Inspect the seal rings for cuts or tearing. How do you repair it? Usually emery cloth or a file will handle the problem. Any serious damage should be referred to the tool pusher because the unit may need to go into the shop. What should be lubricated? All the sealing surfaces of the parts, as well as the seal rings, should be lubricated with a silicon-based grease or castor oil. Petroleum products will damage the seal rings. Replace any damaged seals and replace the packing unit if it doesn't test out. It's that easy. And the BOP is so vital to your safety, there's absolutely no excuse for you to neglect it. Whenever you're in doubt about a procedure, use the operator's manual. The manual spells it all out. Treat your blowout preventer like your life depends on it. It does.